Welcome to lesson 5. Okay, last class we talked about the loft command, the sweep command. We talked about pipe. Then we went into modify. We talked about press, pull, fillet, chamfer, and shell. Okay, now the rest of these commands, we also did talk about combine, but the rest of these commands are not that critical for now. So you can experiment with these, but some of these are actually subcommands of some of the stuff we talked about, like offset face is actually another name for press and pull in most instances. We will touch on these four: replace face, split body, and silhouette split. But we did talk about split body a little bit. These are not that critical. It's very easy to experiment on your own. However, we have some critical things that we need to talk about, and we'll start with the idea of creating sub assemblies and assemblies. Okay, now there's a very minor difference between some other CAD programs and Fusion. Fusion calls everything bodies or components, and it doesn't have the feature of assemblies as a separate entity. So every component can become an assembly, and I'll demonstrate that with a very basic, by creating a very basic sketch and a body. With that sketch, create a box. So this is a very simple prism. As you can see on the tree on the left hand side, we have what Fusion calls unsaved until you save it, and as soon as you save it, it asks you for a name. Okay, let's call this box 1. Okay, now as you can see, we can see the box 1 with a V0 next to it, which just became a V1. That means this is our first version of a save. Okay, now when you go into the data panel, you'll see that the V1 is also here. Okay, now if you click on that V1, Fusion will show you all the history of your saves. So Fusion keeps the current state of the item in its saved state. Okay, so if you need to go back to a certain save, you can select it from the history. However, the important thing is Fusion now has this box 1 as a component. This is a component. Okay, now let's close the data panel for now. And in this component, we have, on the tree, you can see we have a single body. Okay, now if we wanted to turn this into an assembly, all we would have to do is create another component, and we can do this inside of this box 1, or we can do it separately. Now, as a general rule of thumb, creating separate components in other components is a better practice than creating everything in the same component. And what do I mean by that? Now, if I were to create another component inside of this component, and I'll do that for demonstration purposes, I'll right-click box 1, and I'll say new component, and I'll give it a name. I'll say sphere 1. Okay, Fusion creates this component under the tree. So the hierarchy, as you can see, shows us that sphere 1 is a subcomponent of box 1. And if I keep creating other components in box 1, they will always be subcomponents of box 1. However, if I wanted to make a component that is not hierarchical, in terms of hierarchy, not under box 1, I would have to create a new design, which I will also do. But let's create the sphere here. Let's create the sphere. Now, a minor feature that you have to watch out for in Fusion is when you start working with components, you have this small check mark box, let's say. Now, as you can see, the check mark box, we should call this something else, the marking box, let's say, is empty on this one, and it's full in the sphere 1. That means I'm working on sphere 1. And when I hover over it, it says active component, right? If I want to go and work on box 1, I can go and select this one with the left mouse click, and now I'm working on box 1. And you can tell because the box 1, the box in box 1 is not transparent anymore. Okay, when I move into the spheres components environment, the box becomes transparent. Okay, now let's do a sphere. Okay, let's actually make it from a solid, and we talked about this. Let's do it this way. Okay, let's make that. Okay, so we have a sphere and a box. Now, as you can see in the history timeline, it's not showing me any history about the box. The reason for that is because the active component currently is the sphere. When I move into the box, when I make that active component, it's showing me the box and the sphere. And that's because of the hierarchy. The sphere is under the box, okay? However, there is this color coding on the top. You can see that the box is something like a pink color, and the sphere is something like tan color, okay? And if you guys remember, I mentioned something before. I said when I'm working with multiple components, I usually turn on this display component colors, okay? When I click that, everything that was gray turns into the color that you can see here on the left-hand side or down below, okay? And Fusion, by its own account, decides on which components get which colors, so you don't have to do anything, okay? Now, working like this makes it easier. You can, especially when you have multiple components, you can tell which component name matches with which color. It's much easier this way, okay? Now, I have two components. I have the sphere under the box, so there's a hierarchy. However, when I move into the sphere's active component environment, I can only see the sphere. I can still manipulate the sphere. I can, let's say, make it bigger, okay? And nothing else is affected by this change, okay? Now, if I wanted these two to be equals in terms of hierarchy, I would have to create them as components. What does that mean? Okay, let's do that. Let's open a new design. And instead of working directly from the beginning in this environment, I create a new component, okay? I say, for this example, box 2, okay? Now, this is important because I have no body and no sketch in the top hierarchy. I'm working directly in the component right now. Okay, let's create a box again. Actually, let's do it with a solid. Okay, let's do it with solid. Okay, so there's my box. Okay, Fusion decided this to be green. That's fine. So I go back and select my active component, and then I say another new component. This time I say sphere 2. Now I'm in the sphere 2 active component environment, and I put the sphere down. Say something like that. Okay. And then I select the home environment. Okay, and I give this a name. I'll say save. I'll say prisms. Okay, so if you look down below in the history now, you can see that in my home environment, in my topmost component, I have all the history. I have the creation of component icon, this icon, and this icon is the creation of component icon. Then I have the 2 creations, okay? Now I can delete this sketch because I didn't create this box with a sketch, okay? So I have these 2. If I go back to my other design, you can see I only have a single creation of component icon because the first box belongs to the main component. Okay. Now, if you look at the icon in the tree, you can see that the components without any other components in them have this simple box icon. But if a component has multiple components in them, it has this Tetris-like icon with 3 boxes, okay? So that's how you can tell if a component has another component in it or if it's just by itself, okay? So these 2 are just by themselves, okay? Now, if I'm working on one of these and if I make it active, and if I go and say new component, I can create a component inside of them. Let's call this small box 2. Okay. Now you can see that the box 2 icon has changed into a multiple component icon. If I close up the tree, the difference is much more obvious. And the sphere icon is a single component icon. Okay. So in terms of hierarchy, the prisms does not have any bodies in it, no sketches in it. The box 2 component has another component in it called small box 2. And the sphere component, which is under the prisms, does not have any other component attached to it. Okay. Now, let's select the prisms top hierarchy as the active component. Now, this is important. Why? Because if I'm selecting the prisms as the active component, and if I make changes to any one of these components, the history is going to mark that as such, and I'll demonstrate that. Okay. Let's say I want to open up a hole on top of this box. Okay, let's make it a through hole. Okay, and now, as you can see in the history, it's marked that feature in the color of the box. Okay, so it knows that I'm doing that to that component. But But here's the important thing. Look at the color of the sketch. The sketch belongs to the topmost item. It belongs to the prism, okay? Let's do the same thing on the sphere, but let's do it while I'm in the sphere, while I have selected the sphere as the active component, okay? Let's make a sketch, and let's do it on this plane. Let's create a hole through it. Just an arbitrary hole. Okay. Okay. Now, look at the color of the sketch. It's in the sphere's environment. Okay? If I go back to Prism, you can see the difference. The hole in the box has the sketch in the Prism environment, but the extrusion, okay, is in the box's environment. However, in the sphere, the sketch is in the sphere's environment, and the box, the extrusion from the hole, I mean, in the sphere is also in the sphere's environment. So, if I select the box, I can't see the sketch. If I want to only modify the box, there is no sketch in the box's environment because the sketch belongs to the prism. I can also see this when I look at the prism. When I go down, there is a sketches tab now, okay? This tab belongs to the prism environment. This isn't good practice. Good practice is to make all your modifications on your components in their own environments, okay? So if I want to do something else to this box, it's good practice to make the box the active component, make my changes. Let's say I'm going to put a face fillet, okay? Make everything filleted on these three faces. Say okay. Then go back to the prism environment to have a look on what's happening, okay? This way, I know that every modification I make belongs to that component. Now, why is this important? It's for one of these reasons. First, you can track all your changes according to the components in the history timeline. Second, when you export these components to use them elsewhere, which you can do. And as an example, I'm going to export this sphere. I'm going to say export, okay? I'm not going to export to my computer. I'm going to export to a project in the cloud, and I'm exporting this to the Teams, okay? I say export. Now I have this sphere as an item under my data panel, as a component under my data panel. Okay, you can see it here. And what I'm going to do is I'm going to go into our first design here, and I'm going to import it into this design. Okay, I'm going to say insert into current design. Okay, here we go. Say okay, I like the placement. Okay, we can close this. Now you can see on the tree that I have an imported sphere, okay? Now, there is this small chain icon, okay? This is important. Why is this important? I'll show you. I'm going to go back. I'm going to go back to my data panel. I'm just going to open this sphere as a separate component file, okay? Here's my sphere. And I'm going to say, well, I don't like the placement of this hole, okay? I want to change it. So I'll edit my sketch because I can edit my sketch because it belongs to the component. I'm going to pull it towards the middle, okay? And say finish sketch. Okay, that looks better. I'm going to save it, okay? You can give version description names if you want, okay? I'm going to say okay. I usually leave it at user saved. Okay, I'm going to go back to box 1, and I have this small exclamation mark now on the chain. I also have it on the top, okay? And if I press that and right-click it, okay, I can say get latest version, okay? So I'm getting my latest version. When I get my latest version, you can see that the hole is in the center. So this chain icon allows me to link files from my data panel, which can be automatically updated when I make changes in that file, okay? So if I were to, let's say, make a, or not, no, let's not make a sketch. Let's delete that sketch. Let's make a fillet on these edges. Okay, let's make a fillet. Okay. When I save it, okay. Anytime I make changes to the original component file, I get a chance to update my design using this link. Okay. Now, this is the advantage of it. There is a disadvantage. You can't make any changes in this box assembly, okay? I guess I should define that because this might be confusing for some people. Assembly means, and it only means, nothing else, if you have more than one component in a file, that is an assembly, okay? Now, Fusion doesn't usually use the name assembly, but in terms of literature, when you're looking at CAD file, other CAD programs as well, you'll see the name assembly, and the only thing that states is you have more than one component, or what other programs call more than one part in the same file. In this example, I have 1, 2 separate components and one component belonging to the main file, okay? So this is an assembly by all means, okay? Now, as I was saying, as long as this chain exists, you can't make any changes to the sphere. Now, if I want to create a sketch, let's say I create a sketch, and I want to create another hole through this, like something like that, okay? Let's do that. Okay, and I say cut, okay? It says, no target body found to cut or intersect. And if I click more info, it'll show me if it has any details. It can't cut this part because this part is linked to its main file. Okay. But let's delete this. Actually, let's keep that sketch because we're going to do an example with that. I say finish sketch. Let's keep our circle. If I'm sure that I'm not going to modify the original file, and if I'm sure I'm not going to use the original file as a linked file, I can right-click this linked file and I can say break link. Okay. As soon as I break the link, the color changes and the chain icon goes away. That does not mean the original file is affected. The original file is still here. You can use it in your other designs. But in this specific design, this sphere 2 now belongs to this assembly. And now, if I want to cut it or do anything to it, it's just going to act like another separate component. this stuff might be a little bit hard to grasp, but you should definitely practice with this, because most of the time, in most of the designs, you will be working with more than one component. You have experienced this last class with the flute. Now, the flute that we did last class had 4 parts, okay? Each of them should have been a component, okay? Because there are things that you can do with components that you cannot do with bodies, and we're gonna touch on those, okay? Let's take a small break. Okay, so I'm guessing you guys understood most of the stuff about components, assemblies, and parts. Let's do a real fast recap. This design file is an assembly file because it has more than one component inside of it. However, Fusion does not use the term assembly. It uses the term component, even if it has more than one component in it. There is a way to differentiate it by looking at the icon. A single component icon is a box, a single box. A multiple component icon is a multiple box, like a Tetris part, okay? Every component can have multiple bodies in it, but there is a difference between using bodies and components, and that's where we're at right now. Okay, so what can we do with bodies and what can we do with components? So let's start with bodies. I'm going to close these up. I'm not going to save them. Okay. Now we have a fresh new design. I'm going to make a sketch and I'm going to create two bodies inside of a single component. Okay. That's body 1. You can see it here. I'm going to rename that, call it box 1. Okay. And I'm going to create another sketch and create another box. This time a little bit smaller. And I'm going to say OK and call this box 2. Okay. Now, as you can see, or the first thing you should notice is these bodies are the same color. Why? Because this is called display component colors. So everything inside of the same component gets the same color. Okay. Now let's look at it from the top. Okay. Now, when you're dealing with bodies, there are some things that you can use. One thing that we're going to talk about between components and bodies is the align command. Now, it's possible to align two bodies. You can see I aligned them from the front, and I'm going to align them from the top now. I'm going to say OK. I'm going to go and select align again. I'm going to say align this one and this one. So usually the first one I select will move to the second one that I select. So what does that mean? I'm going to align the bottoms now. I'm going to select the small box, then the big box. As you can see, the small box moved, okay? If I do it the other way around, which I will do right now, I'm going to go and select align again. I'm going to select the big box first, then the small box. You can see the big box moved. So it's good practice to select the one you want it to be moved first, okay? So this is the align command, okay? Now, when you look at the align command, you can see it has bodies it also has components. Okay, so this command works for components and bodies. Okay. Okay. So that's how align works. Align is a good way to arrange your bodies or components without creating any kind of relationship between them. That means that you can still move your components around with the move command. You can still move them. They're not attached to each other, and you can reuse the align command when you need to. Okay? Align command doesn't only work with faces, it also works with edges. Okay? But one thing you should be noticing is when I'm hovering over this component, right, I'm getting different marks. Now, these marks are specific to different types of geometrical shapes. So in a square or a rectangle, in a circle, for example, shapes that Fusion can define as basic geometric shapes, you will get a center point and you will get markers on the sides. Now, this box that is appearing, the four-cornered box, as you can see, is changing direction according to which face I'm hovering over, okay? For example, when I hover over the edge, it looks like it's cutting the edge, it's perpendicular to the edge, but when I move towards the side face, it's parallel to that face. Or when I move towards the other face, it's parallel to that. These are important because this cornered small box that is appearing is the deciding factor on how the parts align. Okay, and I'll show you that. I'm going to select this edge with this shape cutting the edge like this, perpendicular. Okay, and I'm going to do the same on this edge, okay, of the small box. Okay, and when I click it, you can see that the middle of the edges are in a relationship that is non-binding, by the way. Like I said, you can still move these. But you also get this angle, for example. You can change the angle, okay? There are four angles as obvious by this shape. It's this four-corner shape, and you have these four angles. So the box is rotating around the edge, and you can select one of these, okay? You can, of course, flip it upside or down, but the edge gives you this control. Okay, let's uncheck these, and let's do another type of relationship. Let's do a middle to middle, middle of this face to the middle of this face, okay? It's inside of the big box right now. If I flip it, it's outside, okay? And if I click the angle, I can rotate it 90 degrees, okay? So this is the align command. You can also do vertices, okay? Vertex to vertex. You still have the angle command. You can go like that. You can flip it and do the angle command like that, okay? So that's a neat way to create a basic alignment between two objects. Let's cancel that. Okay. Now the nice thing about the align command is you can also see it in your history. So I can delete these, go back to an unaligned state with these two boxes. Okay. Now another important thing in Fusion, which you will use a lot, especially when you do a lot of multiple components, okay? When you need to assemble things, okay? You have this command called the joint, okay? Now the joint is important because the joint gives you full control for relationships between two components. However, it does not work with bodies, okay? Now, for this example, I'm going to show you how to create a component from a body. Okay? And you need to be aware of something which is rather important, is when you right click, let's press escape, let's get rid of these selections. Okay. Oops. Cancel. Okay. Fusion can get stuck on certain selections, like it's selecting these two boxes with blue, you can see. Sometimes this happens, and even though you press escape, it doesn't change anything. Okay, let's try a different command. Okay. When this happens, okay, it's sometimes good to save it. Save your design, close it, and reopen it. You have to wait for this to finish. It's uploading to the cloud. Once it's uploaded, we can control it, open it, import it. There's a problem with this file, I think. Great. This can happen, by the way. This can happen sometimes. It's not that rare. It does happen sometimes when one of your files takes a lot of time to load up to the cloud. It's good to press this refresh button if that happens. Okay. Now, okay. We have these two boxes. Now the selection is working back again. If I right-click on one of these boxes, I get this thing called Create Components from Bodies. Okay. Now you have to watch out for this because this is rather important. When you create a component from a body, like this, it created the component. Okay. It turned the try into a multiple component item. But when I make the box active, you will see that it does not have any history in it. And you get this icon. Okay, this icon means body to component. Okay, this body to component change erases your history. Okay, so I would not do this on items that I'm working on. I would only do this if I have to turn that component body into a component to make some kind of a component only adjustment, okay? And this is what I'm doing in this example. So I'm also going to create a component from this box 2 body. So I have these two components now created from bodies. If you look at your try, the topmost item in the hierarchy, you can see that the history that belongs to those components is still here. But if you go into those, activate those components, you will see that there is no history belonging to them. Okay. Now the history, by the way, works the same. If I make any changes in this sketch, for example, make this longer, okay? It will update as long as this part, these two components, are in the try multi-component design. But if I export them, they will have no history, okay? Now, let's talk about this assemble tab, okay? And let's talk about joint. Now, joint is rather important, and this is going to be the topic of the day. Joint enables you to create permanent relationships between components, and it has multiple options. If you look under motion, okay, in the joint right hand menu, if you look under motion, you will see rigid, revolute, slider, cylindrical, pin slot, planar, and ball. Okay, we're going to do examples of each. And let's start with the rigid. As the name suggests, if you make a relationship with this joint type, your relationship will be permanent and it will not move. It will be rigid. What does that mean? So let's make a relationship between the bottom center of this face and the top center of this face, okay? I can, before I end or conclude this joint, I have the chance to make adjustments, okay? I can rotate it. I can say like this, 25-degree angle, and I can say 5 millimeters between the two. And when I say OK, you can see this small icon appearing. This icon is controlled by the joint tree, okay? If you open up the joint tree, you will see the rigid name for your first joint, okay? You can also rename these joints, which I will advise you to do, because when you start having multiple joints, you might start to get confused, you might start to mix them up. So what I usually do, it's good practice for me, is I say box 1, box 2. So I give it the names of the two components that I'm creating a joint between, okay? So this tells me there's a rigid relationship, this icon, between box 1 and box 2. Now, if I move the green, I can see that both of them are moving, okay? However, if I want to make sure that none of them move, what I do, and what Fusion allows you to do, is to ground one of them, It's like putting a nail into the ground to make sure the one that you choose will not move. So in this example, I'm going to make the orange one grounded, okay? I'm going to ground it, okay? It's asking me, do you want to ground it at the first position that you had it, or do you want me to ground it at this position? So this is cool. I can say revert position. That means it went to the original position before I moved it. Now I'll actually show you that. It's very simple, but it's a good thing to know. Let's say you're working on multiple components and you accidentally moved one of the components, okay? You get these two icons on the right-hand side. One of them says revert position, the other one says capture position, okay? Now, the revert position will go back to the state before I moved it, okay? The capture position, on the other hand, will capture this position, and it will put a mark in your history, okay? That's important because when you go to this, when you right-click this capture position and delete it, you will go back to the original position. So, if you, for some reason, when you're working with multiple components and you don't have joints between them yet, and if you accidentally move some, you can realize that by looking at this, Okay, if you see these two icons appearing on the right-hand side, you should know that you have moved something. I'm going to revert this position, and I'm going to ground my box to the orange box. Okay, now I get this small pin icon on the component icon, and I get this small pin icon on the history. Now, if I want to move my green box, I can't move it. See, when I try to move it, it doesn't do anything. The orange one, that doesn't move as well, okay? And even though I'm trying to move it, these two icons, the capture icon and the revert position icon, does not appear. So I can be sure that I'm not moving, okay? Now, I'm going to unground this, and I'm going to delete this joint. And it goes back to its original state. I'm going to clear my history a little bit, because I don't need these pin marks in my history. Okay. Now, that was the rigid type of joint. However, there are these two as well. When I'm selecting the rigid type of joint, I went into motion and I said rigid. I came back to the position tab and I started selecting my positions. On some of the different types of shapes you create, you might not get these selection parts on your models, okay? They might be organic, or they might be different types of shapes where you don't have these types of straight faces. Then you have other options as well. You have the option to select between two faces. That's telling you that you can create an imaginary joint point between two faces. Let's say between this face and this face, okay? I want to create a joint point between those two faces, and I can do that. Okay, somewhere around here, for example, okay? Oops, selected the wrong thing. Let's go back to joint. Okay, select this, select our two faces. Now I can create a perpendicular joint point on this face, okay? Look at the icon. It's looking towards the face, okay? It's not parallel to it, it's perpendicular to it. And you can see my coordinate lines. These coordinate lines will match my other joint. So you can see that my green line, right? That's the y-axis, it's looking towards the box, okay? Now, if I had selected my simple selection tool, it's not possible for me to have the y-axis look inside towards the box, okay? But when I create between two faces, I can use the outside face of this box as a perpendicular joint point, okay? And on my second one, I'll select this line, this edge, for example, and I'll say, okay, and that moves, and I'll give it an angle. I'll give it an angle of 50 degrees, okay? And that's my joint, okay? That's a rigid joint. It's not going to move, especially if I ground one of the boxes. The two boxes will be completely rigid, okay? Now let's delete this joint, and let's do the other one. Now there is this two edge intersection. This is great for doing a joint when you have a fillet, for example. And let's do that. Let's go into this box. Let's select that as the active component. Let's create a fillet here, okay? And let's select our main component back again. Okay. Now, I would like to create a relationship at the imaginary point. If the fillet wasn't there, I would have an vertex here, an edge going all the way down, and a vertex here. But because of the fillet, I lost those. However, this two-edge intersection type origin mode allows me to do that. I select my first edge, then my second edge, and I get this imaginary joint point, okay? I get this imaginary joint point right where these two edges intersect. And I can use that for a joint, and I'm gonna do that. I'm gonna say, I wanna create a joint with this, okay? Okay, so if I rotate it, as you can see, it turns around that imaginary point. Okay, this would be a great example of a joint for a hinge, for example. Okay, I could create a hinge this way. Okay, so you can see the meaning of these three different origin modes. Okay, simple, between two faces, edge intersection. Okay, and you can use those to your advantage. Okay, let's cancel this. Now, let's move on to another joint type. Let's say revolute. And let's go back to our position. Okay. Under motion, we selected revolute. We went back to our position. And we're going to select a position. Now, actually, let's continue on from the last example. Let's select the two-edge intersection. Get our imaginary joint placement, and let's select this edge again. Okay. Now we have a revolute joint type between these two. What does that mean? Okay. When I click OK, you're going to see a different type of joint icon now. This joint icon is the revolution joint icon. Okay. What does that do? What's different from the rigid, right? To demonstrate that, the easiest way is for me to ground box 2 so it doesn't move. However, this time I can move the green box, okay? And you can see the angle of the joint, okay? You can see the angle changing. It will revolute infinitely between that. However, what I can do something very interesting. I can say, I want to limit this revolution, just like a hinge. I can go into revolute, right-click it. I can say, edit joint, okay? You will see that I have some starting angle adjustment. I can also do it from here. I can say, I want to start from 90, okay? See, angle is 90. I can click OK. Then I can go back to revolute and I can say edit motion limits. Okay. You can see that my icon is highlighted. I can select the minimum angle. Oops, sorry. I can select the maximum angle. These two work together. And I can select the rest number. Now, let's talk about the minimum and maximum first, then we'll get back to the rest. Now, I can enter numbers here, or I can use these small tabs, okay? Now, I'm moving the minimum. As you can see, the minimum number is changing on the right-hand side, okay? And I can keep the maximum at 0. And I say, when I say preview limits, okay, Fusion shows me what the minimum and maximum does. Okay, so this part, when I say OK, this part will only move between these two. I can't turn it anymore completely. There is no infinite turn. However, if you look at the top, when I move this, it's showing me a revert position. Okay, it's showing me a revert position. Even though I'm controlling a joint, it's showing me a revert position. So if I click revert position right there, it goes back to the 90. So if I do that, place revert, it goes back to 90 because I set it at 90 at first, okay? Now I can change that. I can modify that. If I go into Revolute Free, edit motion limits, and include a resting position, okay? See the small tab, okay? The rest position, okay? I can control where it will rest when it's doing these motions, okay? I can enter something manually as well. Let's go back to our original. Let's say 0, and let's say minus 45 for the rest. So this is the rest position. And I can click preview limits again. It will show me the minimum and maximum. When I say OK, it's done. So when I move this once, if I let go, it goes back to the rest, okay? I'm letting go, it goes back to the rest, okay? There's something interesting here that you guys should note. Even though the rest position is at 45 degrees, and it's going back there, if I click revert position, it will go back to 90. The reason for that is I defined the first revolute angle. If I say edit joint, you will see as 90, okay? So it's good practice to define your alignment angle the same angle as your rest position, so Fusion doesn't give you that warning, okay? So I do this, and my rest is at 45, so the model jumps back to 45, but if I click revert, it goes back to 90. I can still do this. I can, when it's at 45 rest position, I can say capture position, and from that point on, that warning will not come up. But you will have this icon in your history, and you might think it's a mistake if you can't remember it. So keep that in mind. It's good practice to make the alignment the same as your rest position, okay? Now, so that's Revolute. Edit motion limits. You have minimum, maximum, and rest. Okay. It's very useful, the Revolute joint type. Okay, let's say cancel. Let's go back to what we had before this joint. Okay, revert position. Okay. Another joint type. We have the slider. Now the slider is useful whenever you have a piston, a moving track, a car, a train, anything like that. You can use the slider joint type. Okay, let's do an example with the slider. We go into motion, we click slider, and the slider wants you to define, the slider motion type wants you to define what's going to slide on what. So, for this example, I'm going to slide this edge over this edge, okay? I'm going to select this edge and that edge, okay? Now you can see the icon is different for this as well. That's the slider icon. And I'm going to say, okay. Then to demonstrate, I'm going to ground box 2, the orange box, and I'm going to move the green box, okay? You can see the sliding action, and you can also see a distance marker, okay? The slider gives you a distance marker, okay, how much sliding is going on in terms of negative and positive numbers, and we can revert back to our original position as well. Okay. The same joint limits exists for slider as well. So if I right click, say edit motion limits, I can define a minimum and a maximum. This is great for pistons, for example. I can say this time, and this one, and this one. Okay. That's the wrong icon. That's the right icon. Sometimes you can't select the right icon if you're doing it from here, so sometimes it's much easier to do it from here. Let's say -12 to 12. Okay, so it's moving between -12 and 12 millimeters. So when I say preview, I can see this sliding motion. Okay, stop. And I can, like the other example, create a rest as well. And I can say rest at 5 millimeters. Okay, so as soon as I move it towards one side, it's going to jump back to 5. Move it 5, move it 5. Okay, move it the other way, 5, 5. It's always going to rest at 5. But remember, because my resting position and my starting position is different, I'm getting the revert position warning. Okay. Now, it's a very easy way to create a pin, animated pin from this. For example, you can create different types of, like I said, linear elements, pistons with this very easily. Okay. Now let's delete these again. Revert back to our position. Okay. Okay. So that's the slider. Now let's talk about the next motion type, which is cylindrical. Now cylindrical and revolute get confused sometimes, so we're going to talk about that with the same example. So I'm going to select the two intersecting edges, and I'm going to select this edge. Okay. Now, as soon as I click OK, you can see I have an icon that is very similar to Revolute, but it has this small arrow as well on it. If you look carefully, you can see the icon is between or includes the same icons from Revolute and Slider. Okay, so what does that mean? Let's ground the second box again, box 2, and let's try and move the green box. Okay. Oh, you can see that I can rotate and I can move it like a slider. So rotation and sliding at the same time. Okay. Imagine the locks on old-fashioned doors, like you can see in restrooms, for example. Behind the door, you slide it and lock it. Sometimes they're not used as much as that much anymore, but you can still see them. That's a sliding and locking action. So if I was something like that, I slide up and turn over the orange box, and I slide down. Now, let's revert, okay, to our starting position. Now, the edit motion limits for this is a little bit more complex. Not that much, but a little bit more. Because you have the motion limits for both types of movement. You have the motion limits for the rotation. Then you have the motion limits for the sliding, okay? Now let's input the motion limits for the rotation. Let's say 90. Nope, minus 90. Minus 90 to 0. Okay, so let's preview that. It's going inside. Let's say 0 to 90 then. 0 to 90. Okay, that's better. That's our rotational motion limit. Then I can say the sliders. Well, I want to make the slider minimum and maximum. Let's say the maximum is 50, the minimum is 0. Okay. Okay. Now, if I click while the preview limits is playing, if I click all limits, it will do a preview of all of the limits. Okay. As you can see, we're going up 50, coming back to 0, while rotating 90 degrees. So, you can do endless things with these joints. Okay. So, that's what I have. I have this limited sliding and revoluting joint. Now you can also animate your joints from this menu as well. Keep that in mind. You can right click it and animate it and then press escape to leave. You can lock the motion temporarily if you need to. Most likely you won't, but you might. Then we can revert back. Okay, so that's cylindrical. It's a combination between slide and revolute. Now the next one is pin slot. Okay, now this is a little bit different than cylindrical. You will see. Let's select the same places for our example. Let's say OK. And you can see that the icon is very similar to cylindrical. Okay, let's ground our box 2. And let's move the box 1. Okay, so it moves on the other axis, which is very interesting. Okay, now when we revert back and go into edit motion limits, you will see that the only real difference between these two is the axis of sliding. Okay, this is very critical. The axis of sliding can be different than the axis of rotation. Okay, now the pin slot and the cylindrical has this nuance which may become very important in different types of assemblies that you might do, because not in all types of motion types that your axis and your rotation is on the same axis. So keep this in mind. We have a different axis of movement compared to the different axis of revolution. So that's the main difference between a pin slot and a cylindrical. Okay, the motion limits are the same. Let's delete these two again, and let's do our latest one, or last two. Now planar. The name is actually very obvious, but there are times when you want to create animations where one surface is moving on top of another surface, but it is controlled by something else. So it is different than sliding, and you will see. Now I'm going to select my first planar surface, and this requires a surface that is flat, and the second surface. Okay, I'm going to select OK. You will see that the icon is a little bit different. Okay, I'm going to ground my box 2 so it doesn't move. Then I'm going to move my green box. Now, it looks like I'm moving it like any movement. But if we look at it from the side a little bit, you will see that I can't take it up and down. It looks like it's moving up and down, but look at the shadow. Look at the shadow. You will see that it's actually moving on the top plane surface of the orange. Okay? I can't move it up and down. Another good way to see this is to look at it perfectly from one of the sides and try and push it up. I can't push it up. I can only push it from side to side, okay, on this plane. However, if I look at it from the front, I can play it from side to side here as well, but I can't push it up or down. I have to stay on this plane. Okay? Now, if I go into planar and say edit motion limits, I get 3 icons. I get a rotation, okay? And this is important because planar and rotation can get confusing, but we'll talk about it. I have a first axis of sliding, and then I have another axis of sliding. So I can define 2 axes that are perpendicular to each other as a limit point. So let's do that. Actually, let's do it this way. For this example, I'm going to create another design. Okay, I'm going to go into a new design. I'm going to create a new component. I'm going to create this as the, what should we call this? The table. Okay, create a table for this. I'm going to look at it from the top. I'm going to create a box, 100 millimeters by 100 millimeters. Then I'm going to extrude this box 5 millimeters. And on top of that, I'm going to create some edges. So the thing that I have inside doesn't look like it's going to drop. So I create some edges on this box, which are, let's say, 5 millimeters high. Okay, so I have this box. Now I'm going to go back to my tree, select the topmost part, and create a new component. So this will be my, let's say, part, for the sake of simplicity. And I'm going to create that part on the surface of this table. Okay. And I'm going to create a small box. Actually, I'm going to look at it from the top. I'm going to create that box right on the edge, and I'm going to say this is 20 by 20. Okay. And I'm going to give it a extrusion of 20. Okay, so I have my box. And I'm going to say select the topmost. So I have these 2 components now. Now, between these 2, I'm going to create a planar relationship. Okay, planar is selected. And for position, I'm going to select. Now, I can't see under this box, right? I can't see the small box through the big table. Now, Fusion has a few options for you to be able to select the small box or parts of the small box. Now, if you know where your models are in terms of 3-dimensionality, you can go to a place that is close by, and I'm trying to select the vertex on the bottom. You can keep pressing your left mouse button until a menu opens up, okay? See, this menu is showing whatever I have under that mouse, okay? Under that mouse cursor. So I have multiple things that I can select under that mouse cursor, and one of them is the face of the small part. But I don't want to select the face, I want to select the vertex. But I actually want to select the face, but I want to select it close to the vertex. That's how I should say it. Okay. That's not going to cut it. So another option is to hide the table while doing my selection. So I can do a selection like that. Another option is to right-click the table, okay, and cancel this. Right-click the table and go into opacity control, okay? And let's say select something like 50%, so it makes it 50% translucent, okay? This is another option. I usually like to hide it instead of playing with the opacity, because you have to keep changing opacities, but hiding it works just as fine. So make sure my motion is planar. I hide the table, and I select the vertex on the face that is closest to the corner. Then I unhide my table, and once a selection has been made on the joint, it becomes translucent by itself. So I don't have to do anything else. Now I'm going to select the table vertex, okay? And that's it. Now I have this weird thing going on because I haven't defined any type of rotational limit or axis limit. So the box is moving planar on this surface. And I'm going to say, okay, let's keep that. Let's ground our table so it doesn't move, and let's move this box, okay? So as you can see, I can move towards the outsides of these edges, but I'm going to revert back. I'm going to make an illusion. I'm going to go into my joints. I'm going to right-click planar. I'm going to say Edit Motion Limits. The first one is I'm going to define the slide 1 axes. And I'm going to say minimum, maximum. And for minimum, because I'm moving towards the left side, as you can see from this icon, is the negative. The coordinate system has these lines towards the positive. We talked about this, as you guys can remember. So I'm moving towards the negative. So I'm going to define a minimum. And I'm going to say minus 96 millimeters. Oops, that's the wrong axis. I want to define, why did I get out of that menu? Okay, I want to define this axis, the minimum, minus 96. Okay. So that's too much. If we open up that minimum is here, maximum is there. I want the opposite. Okay, so what I'm going to do is I'm going to make this 0 as the minimum. For maximum, I'm going to say 96. Okay. Now, 96 seems to be outbound, so I'm going to take 20 off and a little bit more. So 78. No, sorry, 74. Yep, seems to be perfect. So that's my limit of joints, 74. Great. I don't want to see all limits, I just want to see this limit. I'm inside the box. Okay, let's do the other slide. The other slide is going everywhere, so I need to define that as well. Minimum, maximum, let's say 74. This one. Okay, let's preview. Great. Okay. Now let's see what all limits does. Uh-oh. Because of rotation, I'm getting outside of the edges. Okay, let's get rid of that. Let's cancel that preview. And let's go back to rotation. Now, I want to say minimum and maximum 0. I don't want any rotation, okay? Let's preview all limits. As you can see, the box isn't rotating anymore, but the limits, the slider is moving in the limits. Now I'm going to say OK, and I'm going to play with this. So, looks like the illusion is I have something that looks like it's limited by the box. Okay? Looks like I can't move outside of the box because of the models. But in actuality, I used a joint. Okay? So this is a great way to demonstrate stuff such as these. Okay? Anyway, now, there's another way to do this, but we'll talk about this after we finish joints. Let's go back to try. Let's revert back to our position. I'm gonna keep this one open as well, but let's do this first. Now, let's delete this and delete this joint. Okay. For our last joint type, I'm gonna select ball. Now, ball is an interesting joint. It doesn't work with anything other than spheres. So what we need is a sphere. Okay. Let's create one inside of here. Let's create one. Let's create one here. Let's create a sphere, right? Can we create one on the edge? Right there. Make it a little bit bigger. 20, let's say 30. And instead of cut, we use join. So we attached a sphere to this box 1. And I'm going to select active component box 2. And I'm going to do the reverse on this one. I'm going to create a sphere. I'm going to create it. Where should we create it? Let's create it right there. And make this 35 so you guys can see what's happening. Okay. I'm going to say cut. Okay. Let's activate component, main component. So we have these two balls that we want to create a relationship between. So what we do is we select ball type relationship, then we select, as you can see, because it's a sphere, the only relationship that I can achieve is in the center of the sphere. So whenever I hover over it, the center is selected. The same thing happens with the cut sphere, okay, the center. And we have an automatic relationship. But right now, it looks a little bit awkward. So, because the part is inside of the other part. So, let's do this. Let's say, okay, but let's go into edit motion limits. Okay, this is fun because in this mode, you also have 3 different controls. And these controls are called pitch, yaw, and roll. These are exactly what you call them in airplanes. But it's interesting nonetheless. And the one that is selected, okay, controls each axis. So you have a minimum and maximum for each one. So we're going to try and make something that rotates, or it looks like it rotates inside of this spherical hole. So we need to create a minimum and maximum. So let's do this. Let's create something like that. For the pitch, for the other one, let's open up minimum and maximum. Let's create something like that. Okay. And for this, minimum and maximum. Let's create something like that. Okay. Now, let's look at what's happening. Now, because we didn't define our limits that nice, it's hitting the corners. But for an example, oops, we have to ground the orange. Okay. Actually, maybe we should look at this before we limit those, because the limits are preventing me to show you guys the flexibility of this. Okay. Now. Okay. So we have this ball rotating inside of a ball. Okay. So that's a ball type joint. If we start limiting after we do this, it gets much easier. So I would do this. I actually don't want to put a limit on this one. Let's put a limit on these two, because these are more critical. Okay. So that's the first limit. The other handle. Okay. So that's like the second limit. So what does that look like? Something like that. Actually, we can increase this one a little bit. Increase that one, but the other one went away. Sometimes the handles are harder. Okay, 130. Nope, that's the wrong way. So let's do -50. -50. Okay. 130 is too much. 100. No. 150 is not enough. Let's make this 160 and this. Let's make not -10 but 10. No, 70 minus 110. Okay, that looks about, well, 90. Yeah, that's better. And the other one, okay. Stop. Okay, let's put a minimum and maximum on this one as well. Okay, let's animate that one. No, it's not enough. It's going too much inside of that. I don't want that. Let's make that 35. Not that. 95. And this 0. 95 and 0. 90. 90. So I'm not touching the orange, I guess, anymore. Okay. Okay. So I have my limits now. If I animate it, let's see what it looks like. I can go and say animate joint. Okay. Interesting. So that's what a ball joint does. It's very useful, and it's the only joint that works for animated balls or spheres. Okay, escape. So you guys know how that works. Now, I just talked about something else with this box, okay? But this is something that is very CPU intensive, okay? So it uses a lot of CPU power to achieve, but it's much more realistic in some sense, okay? Now to demonstrate this, what I'm going to do is I'm going to go into planar, edit motion limits. And I'm going to get rid of the motion limits on my sliding axes, okay? And you can see this when I move this, I can move outside the box, okay? But what I'm going to do is I'm going to go into assemble and I'm going to create something called enable contact sets, okay? As soon as I do that, you get this new menu in your tree called contact sets, and you get these two icons, okay? Now, if I right-click this, it will allow me to create a new contact set. I'm going to say OK. It's asking me what it should look for in terms of contact. So I'm going to select these two components and say OK. Okay, now there's a contact set. And I'm going to select enable all contact, okay? Now, when I move this box, I don't have the joint limits, but now I have what's called a contact set. And the contact set is Fusion's way of calculating when a body or a component touches another body or a component, okay? So even though I don't have my joint limits, I can't leave this box, okay? So I'm using the planar joint just to prevent the cube from rotating and to stay on this plane, but I'm using the contact set to prevent the small box or the part leaving the table, okay? As you can see, when I get close to the edge, the Fusion is stuttering a little bit. It's stopping and going. That's because there's a calculation being going on, okay? And if your models are more complex, this calculation sometimes takes a little bit longer, okay? So keep that in mind. This is very CPU intensive. So I'm going to disable the contacts, revert back, and I'm going to do that here as well. And it works much better with the ball joint. I'm going to go into the ball joint, edit motion limits, and I'm going to get rid of all of these, okay, minimum and maximum. So I don't have any motion limits, okay? Now, if I rotate this, you can see I can go every which way. But let's do a contact set. Enable contact set, new contact set between this and this, okay? Now, as you can see, I can't move it to that side because it's hitting. I can move it up, but when I try to move it, wherever it touches the orange box, the box 2, it stops, okay? So this is a real ball joint. This is how a real ball joint would work. It would stop as soon as the part touches, okay? You can see it's touching there, then it's touching there. If I look at it from the right, I can see it like that, okay? So that's a contact set. Like I said, again, it's very CPU intensive. So it uses a lot of processing power on your computer. So don't use it all the time. Disable my contact set, revert my position. Okay, so those are the main joint types. Now we're going to touch into the other ones a little bit because they're much easier to understand after this. So I'm going to revert back to my original position. Delete. Let's keep these. Let's keep them like that. Okay. Now, We don't have any joints, as you can see. Under the assemble menu, you have duplicate with joints is for another time. As-built joints. As-built joints are very useful when you know your components are in the right place when you built them. So you can select as-built joint, then just select your components and say OK. Okay? That's a rigid joint, and these components are now attached together. Okay? I didn't have to create any other kind of relationship between them. I just created an as-built joint. Okay? I'm guessing the name is pretty clear. Okay? Now, joint origin is very interesting. You can create joint origins on places that are not defined by your surfaces on your models. Okay? That means, let's do this. Let's make a sketch on this box, and let's put a square as such on this box, on this plane. Actually, let's define that sketch so it makes a little bit more sense. Let's define it. Let's say 7 millimeters from there, 12 millimeters from there, and this distance to here is 15. Okay. So that's more or less defined. Okay. I can go into assemble, I can say joint origin, and I can put a joint origin right there. Okay, on that sketch. And I can say OK. Now I have a joint origin right there. Now what's that good for? Well, what if I wanted to make a joint with a vertex, an edge, or a face that wasn't available on the model? Well, I can do that with a joint origin. Say joint, let's say revolute, and I can say this joint and that joint. Okay, now I have, let's ground that so we can see a joint between these two. Oops. Okay, that is controlled by my newly created joint origin. Okay, and with a sketch as such, I can create many different types of joint origins. Okay, let's small break. Okay, so let's talk about the other ones real quick. As-built joint, joint origin, those are fine. Now, rigid group. So I'm gonna delete all of these, revert back to original position. Now, if you have a lot of components, let's say I have multiple components, so I'm gonna do something. I'm gonna copy this. I'm gonna say create copy on the right hand side. I'm gonna move this. Okay, so I have another copy. Okay. As you can see, the copy is the same color. I'm going to create another copy from the copy. I'm going to say something like that. Okay. Now I can move all of these individually. Okay. Revert back to original position. But what I can do is I can also make sure these are all a group. And when I want to do that, I can say rigid group. And in this rigid group, I can include multiple components. It says 4, as you can see. Now, sometimes you might need to expand this. It says 4 selected. And it says include child components. Now, if one of my components was a multi-component item, then it would include the components under it. So that's a new term. And what does that mean? Okay. In a hierarchy in a hierarchy tree, the top is always called a parent, and what's under it is called a child, okay? So the parent here is the try1 component, and the children are box1, box2, box1, copy 2, box1, copy 3, okay? These are all children. Now, because I have them in a rigid group, I can move all of them, okay? They're in a rigid group. The difference between as-built joint and rigid group is, in an as-built joint, you can define different types of joint types. But in a rigid group, all you can do is make them rigid, okay? So the name should suggest that, but I should also explain it, okay? Now I'm going to break that rigid group. I'm going to say delete, okay? Then I'm going to delete the copies as well. Okay. Now, we have what we call a tangent relationship next. Now, a tangent relationship is available between two components with controlled surfaces, and that means geometric shapes. So what I can do is I can create a tangency between this curved surface and this flat surface, as you can see. And when I say OK, instead of a joint type, I get a relationship type called a tangent relationship. Now, if I were to ground this orange box and move this green box, I can show you guys that because of the tangency, it acts like a planar surface, okay? It's acting like a planar surface. However, the tangency is also controllable towards the end, okay? See, because it's not a planar, it can move on other surfaces as well, okay? The tangency relationship is not confined to a single surface, so the tangency is always there. And this is very hard to control, but when you need items moving on each other, you know you want it to move on each other, then you can use this. And for an example, I'll do something else. Now, let's create a new design. Let's create a component inside of this design. And let's call this a track. Okay. And for this track, I'll create a sketch on the right-hand side. And I'll use a slot type for this sketch. Let's look at the sketch from the front. And for this slot type, I'm going to start from the center and make something like that, okay? So this is a track. It's like a racing car track, okay? So this is my track. And for the part, I'm going to go into my top tree item, create a new component, and let's say this is the bearing. The bearing, okay? And this bearing, I'm going to define on the right-hand side, on the right plane, somewhere around here, okay? And make an extrusion. Something like that, okay? Say okay. Okay, so I have my track and my bearing. Now, I'm gonna make sure my track is grounded so it doesn't move, but my bearing is free to move. But I'm gonna create a tangent relationship between the outside of my bearing and the track, okay? Now, the track, when I click OK, the track is as you can see, where my bearing moves, okay? Now, like I said, it's very hard to control, but the tangency always remains, okay? Now, if I wanted to control this better, I might have to define the track a little bit more. How can I do that? Let's create another tangency between this and this, okay? Now, this is interesting. It's a warning, it's not an error. It says, do you want to continue with this? Because you already created a relationship with this component before. You can say continue, okay? Now, if you can see, I'm having a hard time passing this line, okay? This line is giving me a hard time. So these two relationships don't really like to exist at the same time. So you need to make sure you're creating the right type of relationship, okay? Oops, what's this? Okay. What I can do is I can change my tangency relationship. I can move to this. It's still giving me a problem, and I can't get through this line. Let's see what happens if I move to something like, or let's try something else. Let's try, instead of a capsule, let's try something that doesn't have a line. Okay, let's delete this relationship. Okay, and let's create another component. This time, let's create a track that is round. Okay, and let's do it in the same right plane, revert position. So everything is back to its original state. Let's create something like that, and let's extrude that. Okay. So as you can see, the cylinder doesn't have a line on the outside. Okay. So let's see what happens if I create a tangency relationship between these two. Let's ground our track too, so it doesn't move. Tangent relation between this and this, okay? Now, it's telling me, I want to see that error again, because it's important. This and this, okay. Because there are conflicts with the assembly relationship in design, okay? It says there is another type of relationship that's going on, okay? You need to get rid of that relationship first. Okay. Let's see what happens if I move it over here. Okay. And say capture position. Let's see what happens. Okay. It's still giving me the same error. So let's look at what I have in terms of a relationship. Do I have any types of relationships? No. Okay. While that's giving me an error, I'm going to do something. I'm going to make it look like this is not a functional item. So I'm going to say, get rid of unground this, okay, and make sure that is it remove. I'm going to remove it from the equation. Okay. Now, remove is different than delete. Okay. Remove does not delete anything from the history, but adds this small icon that's telling Fusion that this item existed, but it was removed from the equation. So if I delete that, it will come back. Okay. So let's try it now. Okay. Still, there is a relationship. Okay, this looks a lot like a Fusion error. Okay. So let's do another design with the same items. Because that's like a Fusion error. Let's create a new component. here called track in a new design. Okay, this time let's do it on the right plane. Let's create a circle for a track. Okay, let's extrude that. Okay, now let's create our small car. Okay, let's call this car this time, not a bearing. Okay, let's work on the right plane. Let's create a small car. Extrude that. Okay. Select them. Select the topmost parent, and let's ground our item, our track item, and let's do it here. Tangent, tangent. Okay. Now, because I don't have a line on my cylinder, I can move it anywhere. Okay. But this jumping toward the front surface is very irritating. I don't want that. So what should I do? Is there a way to prevent this? Of course. The easiest way, and the way I recommend in these kinds of relations, is also to create a joint which is planar. Okay? So, planar joint between this and this. Okay? Say continue. Okay? And say flip. Say okay. Now, I can make sure that this red car isn't going to jump onto this surface because of the tangent relationship, but I'm also making sure that the tangent relationship works on the outside surface. Okay? As you can see, because I have a tangent relationship, I can move it like that. Okay? Now this is much easier on the circle. What would happen? Whoops. What would happen if I did it here? So I need to go back. So what I do is I delete remove. I get my track back. Then I delete my unground. I delete my position. I can go back to deleting everything. No, I don't want to edit it. I can go back to deleting everything like that. And let's try it here. Let's try what happens here. So I can delete this as well. Have only one track. And create a tangent relationship between this and this. Okay. Oops, I'm getting stuck at the line. So let's do this. Let's create a planar relationship between these two. That and that. Yes, I want to still do it. And I want to flip it and say okay. Okay, so let's see what happens. As you can see, I can get past the lines. Now, this way, I can create items that move around objects and stay there. But as you can see, I need two different relationship types to make this possible, or it gets stuck at the point the surface changes. Okay? And by doing this, I'm preventing the item from jumping all around the object, because tangency is component based, not surface based. Okay? So now you know tangent relationship as well. You need to experiment with it, of course. Now, drive joints and motion link is a future topic. We will get to that, same as duplicate with joints. For now, I would like you guys to practice, as we will do in-class assignments about joints, about products or modeling that requires joints. Okay? I'll see you in class.